What an honor to be actually with you on the same stage. I think that is really something I was looking forward for quite a while. Because I think what you have done basically for all of us, you have basically built a system that is not running just on our phones, but is running in many mission-critical systems, is running on Mars and many other places. So I think I'm very much looking forward to explore all of that. Quick introduction, I'm Daniel, CTO of Picnic, and we are not only building an online supermarket, but which actually we have not used C++ at that point. But over time, we also started robotics and all kind of mission-critical logistical systems, and then we ended up in the world of C++. So that is actually, I think, very, very exciting. But let's maybe just start with some personal stuff. So when I look back, then a little bit more than 30 years ago, I wrote my first C program, a C++ program, and I was actually proud of it, but it didn't compile. And then I basically looked a bit into it, I talked to my friends, learned that also for them the first version didn't compile. So that is maybe something most of us have experienced. But maybe a question to you. What was the first kind of bigger C++ program that you wrote?
I guess it was the compiler. I bootstrapped the stuff out of C, and then C with classes, and then C++, and then other people built compilers also. I haven't built huge C++ programs for a very long time, because my role very often has been to be part of a team that built big things. And so I help with ideas and design and techniques and things like that. So I still write code, but I don't actually deploy code myself. I think that code should be deployed in production by experts that do it full time. And people that are doing sort of ideas and techniques and helping training and such are not full-time expert, and are more likely to make mistakes. And so I ban myself from actually doing the final deployment.
Do I hear a confession that you consider yourself no longer an expert?
Not in these systems we're talking about. I mean, I spent about half of my career in industry and half my career in academia. So I give talks, I travel to places like here, I write papers, I do experiment. That I'm reasonably good at. But if you take something like a security program in a bank that you can easily cause millions or billions of losses, then I want people who do it full time. I did work for a large bank for 10 years. I was a managing director who wasn't managing anybody, and a technical fellow. But I worked with teams, and teams in the plural means that I'm not a full-time expert in anything.
Can you talk us maybe a little bit back to the kind of the early days and when you came up with, let's say, the core concepts of C++, and when, let's say, when we're talking now about, so this is a room full of technical leaders, CTOs and C-1 leaders, etc., that are often thinking about building systems that last. And when we are now talking about building systems that last, we're already happy if our code survives 3 years, 5 years, 10 years is already a big achievement. Most companies are not even 10 years old.
That's right.
What you have achieved basically is a language that after, 50? 60?
No, not quite.
40, many years.
Make it 45 or something.
But is still there and is very much highly regarded and appreciated. How did you design a language like that?
It's still spreading, actually. As far as I could tell, we're growing with maybe 100,000 developers a year, some number like that. Of course, it isn't news, and then you don't hear so much about it, but it does. I guess I should point out one thing first of all, is that I was working with Bell Labs at the height of Bell Labs, and they did a lot of inventions that we rely on today. They were doing things in microprocessors, in computers, in microelectronics, in fibers, in software. I mean, all our cameras are built on stuff that came there. All our operating systems came out of there and such. And they had something that might be career death today, but it worked because it was a company at scale that financed development of new stuff systematically and over a long term. So when I got a job there, my job description was very simple. You do something interesting, and if we like it, and tell us next year, and if we like it, you'll get the same job again next year. And I kept it for 16 years.
So they liked it?
They must have liked it, yes. And it was a very collegial group. You could always walk in and find an expert in whatever you were talking about. Networking, compilers, algorithms, and so you learned a heck of a lot. So having an organization that's collegial and has a diverse set of experts is something I really, really like. It may not be the way of doing an optimal startup, but that was what I was doing. I served 7 years as a department head there, and so I guess I've been in some form of management for 17 years or so. So I don't claim to know everything, but at least I've tried something.
That sounds for many of us pretty much like the kind of the dream environment where you get a lot of freedom. You can explore basically all your ideas, and you get also the time to explore it.
They were very picky about who they would hire for that. That's natural. And also, it's a thing for a large company that can afford that. They actually had another computer organization that was controlled and directed in the more traditional way. But the Computer Science Research Center always won in terms of delivering goods for the future.
And if you switch a bit to the perspective how we, let's say as engineers and as tech leaders are developing software today, iterations are very fast. Many of us are using AI-assisted coding tools. Some of us are also doing quite a bit of vibe coding. How do you look to that type of generation, that way of, let's say, engineering systems?
It's not what I'm doing. And it has a lot to do with what I'm mostly thinking about. I'm thinking of traditional engineering things. I mean, it's fine to have Python and it's fine to have everybody programming, but I don't want them to program with the brakes of my car. I want a guarantee that when I press the pedal, it actually stops in a reasonable way. And so I'm aiming for experts. And vibe coding and a lot of sort of scripting coding in Python doesn't fit that pattern. And I'm particularly worried that people forget that there is this serious engineering kind of programming that is not what the majority of people are doing. I mean, maybe, I don't know, maybe 80% of all coding is what I would consider sloppy. And it doesn't matter that much. If a little website for a few dozen people crash, so what? If my video game crashes and comes up again, so what? If my bank account gets raided or if a plane goes down, it matters a lot. And I tend to think about this. I was exchanging information with a friend lately, and we were talking about air controllers for scuba diving. It's better not break. This is where you get a fatal crash.
Do you see a world where things like vibe coding, or at least, let's say, coding assistant systems could marry with the way how a typical C++ engineer would work?
I don't see why not, but I don't see how. I'm not an expert. My contribution to AI LLMs is, whether I like it or not, fairly major. TensorFlow, Llama, DeepSeek, they're all built on C++, and I know nothing about AI.
So obviously, C++ is rich on many interesting features, but I guess if you now look back with the wisdom of after 30-something years, do you have any regrets of features that you added that you think, if you would design it from scratch now again, maybe you would have not added or in a different way?
Not really. I think I got the major parts right. If you saw them on one slide in the morning, and it's basically things I want, guarantees I want, and it's not so much syntax and language details. If you look at my book from '95, Design and Evolution of C++, it has some fundamental ideas, and about a quarter of them has to do with language design. The rest has to do with how do you actually use a language? What kind of guarantees do you want? What kind of help do you want? And I think that's actually what C++ did right, as opposed to getting every little detail right.
Yeah.
There are people who claim I was lucky, but to be honest, I don't understand how anybody can be lucky for 40 years.
Of course not, of course not. I will open up in a few minutes just to the room, so whoever has a question, think about a question, raise your hand, and then somebody will come with the microphone. Maybe just a kind of a question. If you have to choose, or if you would have to pick a language that is not C++, what is the second best language that you would choose?
I always waffle over this one, and you won't get a straight answer.
What do I need to do to get an answer?
You won't. You should know a variety of languages. I mean, I have never built a system that used exactly one language. I mean, even in the early days with C++, there was also C, and there was Fortran, and there was Shell. You always had a scripting language to tie things together. And in the same way, you should know some language, some functional language, some language with a nice infrastructure building it up, and things like that.
Let's play maybe a small game, a rapid fire reflection game. So I ask a kind of small question, and whatever pops to your mind, just share it with us. I asked already about the second favorite language, but what is the most underrated language? Maybe I'm getting no one. Also.
No, there's many candidates, and I don't know. I mean, I think, for instance, Ada is underrated and unfashionable. It's criticized, that's fairly, but it's usually criticized unfairly for the wrong things. And I think that's not uncommon. And I reckon it's easy enough to design a language. The hard thing is to get it into use. There are lots and lots of obstacles. We do not write code in a standard or in a manual. We write it in a tool chain. And we need a language that can fit into a tool chain. This was a major reason I wanted to deal with C, despite its obvious flaws, because it fitted perfectly into Unix, and I was working in the Unix room, so I had Dennis Ritchie and Brian Kernighan down the hall, best possible support, and you could actually build things with it. I am far less interested in programming languages than I am in programming, developing systems. I came out of operating systems and machine architecture, and I just happened to have a good classical computer science education, so I wanted to build a compiler, so I built a compiler. It's not that difficult, especially not in those days. Good broad education is important because you can grasp opportunities when they fly by.
What do you think? What is the reason? So there's all kind of discussion, and I guess companies like Palantir are putting it to an extreme, that kind of computer science education is no longer valued in the way it has been.
Have you noticed that organizations that push that kind of idea tend to use different languages and different techniques and different people from what they want their users to use?
Obviously they do.
That way they can monopolize it. Their users cannot compete with them because they can't handle the hardcore engineering that they need.
That is a absolutely correct insight, yes. Very good. I would actually like to open up the floor. Who from the crowd has actually a question? If you have a microphone, we have a question here in the front.
Hi, Oscar here. Why C++? Why not C++?
C plus is a syntax error. And apart from that, there was an awful language called C plus at the time.
Thank you.
That is a great question. I'm sure that we can top that.
Hi, great seeing you. I've been C++ my first language. I was like 10 or 12, so I really like the language. And I'd like first to frighten you a bit. My wife is at a German car manufacturer, C++ code base. The last car was shipped with 1,600 known bugs. So, but my question is, my real question is, I recently inherited a large organization, hundreds of engineers, and we have a 30-year code base C++. I cloned it, Subversion has 44 gigabytes. What are your top 3 core advice elements to get a grip on this code base?
To do that, I've been working on code guidelines for at least since 2012. I wrote the guidelines for some planes. And guidelines are good, but they don't work at scale. You need enforced guidelines. And I'm trying to get enforced guidelines into the C++ standard. And I'm very disappointed they're not in C++ 26, next year's C++. The framework exists, but it's not standard, and it will probably be open sourced this year, but I'm not sure. The basic idea is that people want different things. C++ is a general purpose language, and one of the strengths is that it can be used for many, many things, and large organization uses it for different things. So that's good. On the other hand, you have to enforce constraints. Teachers want simple to teach. Say the US government wants no memory leaks. I want no resource leaks. There are timing constraints in places. And the idea of what I call profiles, and I'm working on, is simply that you can define a profile which restricts the language to something that suits you. And then you put in a static checker that makes sure that you don't use the dark corners that you shouldn't. And I refer to this as a subset of superset facility. First, you extend the language with libraries and things like that, like you put in a hardened library that checks all range errors. And then you can simply with static checking eliminate all subscripting of raw pointers, which cannot be checked. And so I have about 10 profiles I would like in place. A few of them can be done using the C++ core guidelines. They have profiles, but they are not standard and they are not universal. There's a fair bit in Microsoft static checker. There's some in Clang tidy, and there's some in what's it called? what's that browser? J something or other. Doesn't matter. It exists. And it's not perfect, and I want it standard and much better. And I can handle up to and including things like dangling pointers and detect them all before you start. And so I'm working directly at the set of problems.
Which car manufacturer was this?
All of them?
All of them.
I'd like to know too. My name is Philip. Thank you. I'm wondering, how do you think about languages and how are we going to build software in 5 to 10 years? What's your best guess if you extrapolate current developments out? Are we going to see a resurgence of human hand coding? Is it going to be all AI? Is it going to diverge? I'm curious of your thoughts.
I think that in the field where I am interested in, the first thing I said, I think teachers and professors and such should not think programming as one thing. They should specialize. In particular, they should distinguish web apps from infrastructure and engineering applications. And I'm interested in infrastructure and engineering applications where I think we will, if anything, see more hand coding and more emphasis on understanding the problem, analyzing the problem, and precisely specifies what we are doing. I see a greater emphasis on types and of declarative programming. I said earlier, and I'll repeat it to the cows come home, I am not an AI expert, and I would rather not guess about the areas where I don't have personal experience, which is the kind of places where I suspect AI will be more important, and I suspect that there will be some AI support in the fields I am interested in and I know something about. On the other hand, I worry that too much is being put to AI so that we lose the skill sets to actually evaluate what comes out of the AI. I look with horror at what happened when we outsourced and outshored software development and engineering, and bean counters fired the people that had the skills to evaluate the quality of what came back. And I fear something similar might happen with AI if we're not careful.
Can I ask a follow-on question? So let's stay a little bit closer to home. Let's skip maybe the AI side. But there's quite a bit of debate about should we maybe, when we're looking to building teams, and maybe the ideal team in a couple of years, should we more go to full stack or polyglot engineers, or do you believe that, let's say, there are engineers that are really specialized in a specific language, in a paradigm, in a very specific kind of domain, and we should basically compose teams that are complementary on those aspects?
The way I've seen it is quite often, if you have a general purpose language, it's at most the second best language for anything, because a specialized language can always beat it, a domain-specific language. On the other hand, if you get too many languages, cooperating and collaborating and combining becomes very hard. This is one of the strengths of the Java environment, is that they have the Java virtual memory, and all the languages have to basically have the same semantics. It's all sort of syntax on top of that. And you have to work with the people that you have. And I mean, if I was going to build a bridge and I only had carpenters, I would build a wooden bridge, even if I prefer stone. And so I am not a fan of having too many languages. I said earlier that no big system was ever built in a single language, but 10 is probably too many. I can handle 3 or 4 in a context. But it's not just the languages, it's the language that the developers speak. And there are a lot of language fanatics. And I hate language wars. And but they won't talk to people that use the wrong language. And you can get people problems out of language choices. So be careful and try not to go too wide. There are organizations that use 10 different languages and they suffer.
Have you ever convinced people to actually ditch their current language and to switch to C++?
Not a second language, and by and large, I don't go and tell people to ditch anything, and I tend to try and be positive and saying C++ is good at this. If you have this problem, we can help you solve it. And if some other language is fine, then fine. I don't think I've ever gone into a serious language war.
No language war, except English is not a programming language.
English is not a programming language. It's a very useful language, by the way. I once had a debugger, a program that was written in German, both comments and identifiers. And it was a bit of a barrier, but fortunately my reading German was good enough that I survived. But if you get programs that are done in Hindi or Chinese or such, that some people argue is great, we will see the world fracture. And if there was a language that could do everything for everybody, that would help the way English can help with human-to-human communication. But we don't have such a language.
Any other question? Yes.
Thank you. Marcus here. I would like to hear a bit more from you how you think about languages, more from like taking one step back from the like philosophy approach. So, I mean, language wars, yes, I guess we can all agree, right? My language is better than this one, but I feel there's not so much space left for new languages, and there's maybe a good reason that there's just like so much covered already. So if we're deciding what to choose to implement something, the model knows it, there's enough programmers. So is there room to grow? Are there concepts you wish that existed or ideas you've been coming back to but that never materialized? And I mean, stuff like formal verification, etc.
I don't think we're anywhere near the end of development of programming languages. I think that a lot of people drag software development down to the lowest common denominator, and that's where they get maintenance problems and bugs. I think we need better concurrency models. I think we need better static checking. We're working in C++ 26. We're almost certainly going to get static reflection so that you can write a little program that writes JSON out of C++ and reads JSON out of C++ for a given set of types. That kind of stuff is new. And it will take, like all new things, it'll be overused and misused for a few years till we settle down for how we use it, but I think it'll become important. In particular, I think it will help the generic programming, which is something I work on a lot, and still, after many, many years, people still haven't caught up. I think that too many people know too little about programming and is falling back, thinking that C was sort of the final development of languages, or Python or something like that. And people ought to know more, and there's benefits from knowing more.
Thank you.
Hi, Pierre, my name. So when I started to study, we started with C, basically. And I'm bringing that up because you mentioned education. After 2 years, we moved on to C++. And what I really enjoyed is that C gave me the chance to really, really understand how memory management works, for example. Later on in my career, I moved on to more web development, etc. And I realized that this is something that is just not a thing. Nobody thinks about memory management. And because we have so much powers with the cloud computing and everything, we just stop thinking about this. Would you recommend any new engineer to start working with lower level programming language and then move on to any other languages? Because like you mentioned, it's very important to know different languages because you can solve different problems. But I think that the basics of our machines is the same everywhere. So we need to proper memory management. Of course, we can always go back further, like with assembler and stuff like this, but without going too deep in the rabbit hole. How would you approach nowadays education of programmers?
I actually have tried this. I was asked when I was at Texas A&M to write an introductory course in programming. And I was, of course, asked, I was given a choice between C and C++, and I chose C++. That means you can start out with proper resource management, so that memory management is not a problem. I mean, we don't leak. And then, of course, you have to know the low-level stuff. But I teach the low-level stuff, pointers and indices and for range checking and such. At the end, I think it's chapter 27. Because you have to know it, especially if you want to do low-level stuff. And low-level stuff can be things like ultra-low level, ultra-low latency, web shipping of data, or it can be manipulating hardware and such. You need to get there. At least some people need to get there. Maybe not 80%, but as I said, we need to separate different parts of software development. And so I would go for something like C++ done high level, supported by a profile that makes sure that's what they do, so that they don't have memory problems, so that they don't have resource leaks, and then they can learn the low-level stuff a bit later. But you have to, if you want to know low-level stuff, you have to know a little bit about machine architecture, and you have to know a little bit about things like pointers, which are basically memory addresses. But I'm a great fan of static type checking and declarative abilities. Did that answer the question?
Yes, thank you.
So guys, thanks a lot for the discussion. Very insightful. I always have the easy questions, right? I saved 2 questions for now. And one, I think the first one, your slides maybe already have shown this morning, where there was the Mars robot, right? What is the most impactful, from your perspective, the most impactful application of a program that has been written in C++?
Let's see. All of Google, all of Facebook, most of your telecommunications, all the underlying stuff of your cell phones. It's a bit hard to pick a single one. That's the impactful. They may not be the most interesting, but I don't know. For all I know, this microphone is programmed in C++. Most cameras are. It's all over the place. I think what they do at CERN is cool. I think what they do on Mars is cool, but that's a different question. I have a coffee. No, I don't have a coffee machine. I've seen a coffee machine that was programmed in C++. And
I think mine was actually,
my favorite joke is that a programmer is a machine for turning caffeine into code, and I have a coffee machine on my work desk, but you get it from all over the place. On one of my slides, there was a cow barn. There's people using it for running farms. Okay. Chickens, cattle, pigs. It's all over the place.
Okay. Yes, it is, and I think my coffee machine runs it. So I guess yours is then a Mocha Master or something, which is like super old school and simple. I could imagine. And then second question, like follow-up question: what is the funniest application which really made you laugh big time when you heard about that? Is it like a pregnancy test or something, or?
I don't know. I think it's mostly sort of little surprising things. I think the idea of measuring the weight of cows to see if they have been eating enough made me laugh a bit. And I met a guy that was doing bowling alleys. What? But yeah, it's off the top of my head. I can't find something that sort of made me burst out laughing, because you know that's impolite when people tell you something interesting they're doing. They might think it was criticism as opposed to enjoying it.
Okay, I think there was one pregnancy test that was able to run Doom, right? There was like that emulator running on a pregnancy test display. Funny enough, so maybe that's the well, I don't know. It's relative.
There's certainly a lot of medical equipment that's in C++, but you know, I would rather not meet medical equipment. I mean, we would prefer not to deal with that. My dentist used it to model my mouse.
Okay, so guys, thanks a lot for discussions, for the discussion, and for the great questions, Daniel, for the great answers, Bjarne. Maybe like the idea is to always have like a little break where people can network. Maybe they can all meet you outside and take a photo, get an autograph or a signed book, okay. And then we continue at the full hour here. Thanks a lot for being here. It's really an honor to meet you in person, like we met in the podcast before, ages ago. So really great to have you here.
Okay, thank you very much.
Thank you. Big applause.
Thank you.
Applause for